Hella exhausted. Are your exams done yet? I don't know what I'm doing. 3 out of 9? 9? That's crazy. Wow. A lot of exams. It's just like your second year, right? Why, like, is this something special? You're just taking a bunch of different classes. Dang. That's crazy. Hmm. Do longer than regular time. Hmm. That sucks. And it's like in the middle of summer too. Are you getting a break at some point, or are you getting right back into more classes after this is over? I really don't know how I want to start the stream for something to fill with. Long one? Okay, nice. Get everyone spots in first. You know, I can manually. Well, it's still not that easy. 27. This is persisted user global. Twitch. You're beating Jed. Who else might you be in competition with? How many does Thunder have? Thunder has 9. Hey, Waffle. I'm looking through my bot right now. Zach has 4. Alex has 3. Eldritch has 11. I forgot about Eldritch. It's a lot. Anders has 6. Okay, yeah, Spectre, you are indeed in first. I can confirm. And Jet is second. Rain is still uncontested. Long live the king. Hey, Yanis, it's been a minute. The first of first, exactly. That's what Spectre is. I gotta figure out how the hell StreamerBot works to make an actual proper leaderboard with. I keep saying that and I keep not doing it. Call me Spectre. It's very humble of you. Yeah. Been busy? Well, glad to have you here right now, at least. It's super hot outside. I've only just started the stream, but I'm already feeling like super lazy. I'm still not sure if I even want to do algebra right now. Is there anything else that I might want to do? I feel like the math Discord. Um, what's happening here? This is a circle of radius 1 centered at 0, 1. Oh, new recommendation? Okay. To type? Inscription. I've seen a little bit of that get played. I don't know, man. It being a card game kind of like turns me off. Does 2 sine theta make 2 loops over 0 to 2 pi? Is that the issue here? Yeah. If theta equals 0, it's 0. Theta equals pi over 2, it's at 2, because you're multiplying by 2. And then by the time you get around to pi, you're already back at 0. Let me skip just a little bit. Pi over 2. I'm pretty sure that's the problem this person is having. Some fun polynomials today. New polynomial degree less than or equal to n. The integral from 0 to 1 of p times q. Is that for all other polynomials q or certain polynomials q? From 0 to 1 of p times q is just equal to q of 0. That is weird. Yeah, I have no idea who the hell would notice that in the first place. And hey, Joseph. So, okay, you know what? That's so weird that I want to try it. So you give me an example for n equals 1, so let's do another linear. Let's say something really weird. 3 over 2x minus 27 over 5 dx. And so we expect this to be 27 over 5. No, I hope you didn't miscalculate. Yeah, if you lied to me, Yanis, that's the end. You're banned. No. Oh, it is minus 27 over 5. That's weird. And so if we change the numbers again, that's not simplified. There we go. Just slam a 3 on it. Sure. Making up random numbers is really hard. Minus 4 over 9. Okay. It checks out. Hey, Dr. Cook. That's so weird. So bilinear forms. We plugged weird numbers in and it worked. Yeah, exactly. This is, as far as I'm concerned, this is a hard proof. You cannot disprove that. I mean, really, if you, I assume that doing like a transcendental number would break things. Would it? I don't know. Maybe it wouldn't. No, you get minus e there. Well, I guess that only applies to integer code. No, I don't think those would be anything special. No, never mind. Pi and e wouldn't like a. I don't know why they would do anything special anyway. Weird. I want to see this person like types next, but my answer to is there some general way of knowing this is like not really. You have to get used to polar curves and plugging in the easy points. It's a good way to like check things out. Um, how does a discontinuous polar function look? I don't think I've ever actually like. Even what is? Whoa. Interesting. Um, um, 2 sine theta it's a coincidence that the period of sine is 2 pi, but it loops after just pi, because right as the angle go above pi. Hey Jed, yeah, we need a last redeem. Um, two sine theta example is still defined for all theta, but we only care about one loop of it in this context. Okay. sparrows and pedestrians. The number of breeding pairs of sparrows per hectare. I didn't think I would read that sentence or that phrase today. So it's a number of pedestrians per minute per hectare as modeled by the graph below. Okay. So sparrows feel the horniest when 20 or so people are passing by? Is that what they're telling me? They want to be watched, just not watched too much. This is such a weird graph. It seems like it, Jed. Just not too big of an audience. They do get stage fright after a certain point. His eye is on... I haven't heard that phrase. Intervals of increase or decrease? It's an old hymn? Oh, okay. This second sentence or question, that's not grammatically correct. On what intervals rate of the breeding pairs increasing? They say concavity, so we can just go off concavity, but like that's such a weird... That can't be grammatically correct, right? Oh my god, how many questions are they gonna ask? Oh. And I know he watches me. The sparrows do like being watched. No, I wasn't taught that hymn in Catholic school. $1905? Oh, okay. Not on the... Oh, you're not allowed to write it on the graph? They just want to be a jerk about it? We're still increasing between 0 and 3. I don't know why they left that off, but 0 to 15? What? Are they talking about the second part of the question? What the heck? This is weird. Let me, has to be a theorem about it. I don't think of a theorem. You know what? I think algebraically? Okay, I sounded it out. There's no red squiggle, so I must have spelled it right. any... Wait, is that right? It may only particularly work with r equals 0. I feel like you should be able to choose any point you want on the polar curve, but I can't think of a way to actually like make that work. Hey, Steven. I don't remember how your last question was, but if you got a question, I'll try it. Hmm. Yeah, I wish I had a better answer for this person who wants to figure out when a polar loop curves on itself. Or when a polar curve loops on itself. I don't remember a better way than just sketching it, though. Zach, thank you so much. Hope your stream was good. Welcome in, everyone. We're just getting questions off the math Discord and we were helping this person out with a polar coordinates problem. they fell for this common trick where you basically have r equals 2 sine theta, and they were trying to figure out what the domain of, or like, you know, the interval over which one loop happens, and they said 0 to 2 pi because that's a period of sine, which is natural, but since it kind of loops on itself twice, so you actually only want 0 to pi. I was trying to figure out, like, they're asking for like some general guidance on figuring out when a polar curve loops, but I don't think there's a good way besides sketching it. Yeah, thank you so much. Looks like it may have had a question posted in my Discord. Let me just check it quick. Did you give me an entire A-level paper? Oh, no, okay, you gave me a single page. Okay, okay. It's like, I don't know if I'm solving an entire A-level, but... And actually, before I forget, while I have my Discord open, I realize this probably is a long shot, but if anyone knows organic chemistry, I'd love to get Central some help here. It's posted in the Math Homework Help forum right here. So yeah, I don't know anything about organic chemistry, but I just want to get Central some help, so I told him it's okay if he wants to post it here. Just wanted to show that out. I don't know if anyone was like particularly with organic chemistry, so I was kind of struggling with it. And thanks, Zach, for seeing if Dr. Gold knows. I think I haven't seen him do organic chem, but it's possible he knows it. Anyway. What's up with this problem? Another polar. Really? Oh, this is a trick. I think Fembox talked about this trick once, or like when you have a cosine theta minus a sine theta or something like this, you can combine them into a single trig function with a phase shift. How do you do that, though? I forget what the trick was. The quotient of 2 kind of makes it difficult to use. Like, I would want to do a similar difference identity, but the coefficient messes that up. R cosine theta plus a. So if could we maybe work from this part and do a sum identity? Like apply this one? And figure out, well, Okay, if it's a quick one, I can try and do it. Or I mean, regardless, I'll try and do it. But I just started working on this other question from a different person in chat. It is on the longer side though, so feel free to put your question in chat now or whenever. But unless it's a quick one, this one is the one that I'm working on currently. want to see if I feel like I could maybe struggle my way through this. I want to see if there's maybe someone who's worked this type of thing out already, though. In terms of cosine theta plus a, something like that. Doubt nut? Okay. What? That's root 2. Not 2, but... Oh, do we do the same trick, though? Because we do have a 2. Can we say that 2 is the same thing as, like... Well, no, that coefficient... KSPQ. Oh, but okay. Maybe we factor the 2 out. Okay. I mean, they're not calling it F. Just take 2 cosine theta minus sine theta. Okay, so I think what we do is we factor the 2 out. And then are we going to say that... Sorry, 1/2. Does it need to be the same angle, though? There's no single theta. Cosine of an angle, sine of an angle. What I want to do is say that 1/2 is equal to sine of something, and that the invisible 1 coefficient right here is equal to the cosine of the same thing, but there's no theta where that happens. Or I guess we should say phi, maybe. The parentheses there, but not here. This is all... Oh, what the hell, dude? And on the very... Oh, shoot, I didn't even show the question. Yo, Tizzle, thank you for the follow. I swear they're... Like, is this even possible? It probably is, I just don't know the trick, but like... I don't know, like... What? We're not supposed to get that. right? It's ruined like for you now. I've caught myself saying like more often now. What the hell, dude? Okay, well, I also have problems doing this question, I guess. Oh, thanks, Dr. Cook. Because you could take this like sine theta that Wolfram Alpha gets and make it into a cosine with trig identities, but like arctan 2, really? Do you have the answer key for this? Value, the exact value of R and the value of rate of A and alpha in radians. Oh my god. I think they want you to do this numerically? Because I don't think you can do this. I mean, you definitely can't do that, like, through decimal spaces. If they don't let you use a calculator. If some do you want to post your question? I don't know why I'm looking around, but I don't see any like unreads. If you are still here, if you left, it's all good. This is weird. I just dropped my cough drop. It is a cough drop, I guess. I think I'm doing it properly. That one unfortunately falls outside of the 5-second rule window. In like the algebra reading group, I haven't heard of any of those. Oh, sounds good. I'll check it out right now. In general, oh no, I haven't. What? It's like linear algebra? Oh, okay. I feel like linear algebra is one of the things that I need to learn a lot more about. It goes way, way deeper than my class ever even talked about. Okay, so they don't show their work in this answer key, which is unfortunate. Why is R root 5? Okay, if we try working from the other direction, can we figure this out? It's the only thing I can think of. Like, let this thing equal R cosine theta. Oops. And then applying the sum identity to that thing on the right. Cosine, cosine, minus sine, sine. Root 1 squared plus 2 squared? Oh, maybe. Something like that, yeah. So if we equate coefficients here, does cosine alpha equal 1? Is that what the answer key had? Two over root 5? Nope. Okay, if I blindly do what that one website did and use it with Yanis's idea, what we would do is multiply by root 5 over root 5, because 2 squared plus 1 squared is square rooted. But like, this is such a weird way of doing it. So that would imply that R equals, but like, R would equal root 5, and then cosine alpha equals 2 over root 5. Sine alpha equals 1 over root 5. And we don't know what either of those evaluate to, but we can divide them and cancel out the root 5s. So it's 1 over root 5 over 2 over root 5, which is just 1/2. So that's... Well, wasn't it arctane of 2? No, they get arctane of alpha as 1/2. Okay. Sorry if that trauma is being picked up by my mic. It's pretty deep. Was used in almost all areas of mathematics to solve problems. Yeah, it seems really fundamental to a ton of things, including in physics too. That's what Dr. Cook says. It's the linear case first, then we're like, yes, so in general. On the derivative of linearization. No worries, Dr. Cook. Doing that root 5 over root 5 thing is really confusing to me. I guess it always works. I don't really know why my first approach would have been wrong with just... Maybe because you wouldn't get a valid alpha? You would get arctan... I mean, that's how you get the arctan of 2 that Wolfram got. Let's verify that value of alpha. Just... Yes. Four, 6, 3. Okay. 4, 6, 4. Close enough. Okay, that's... I don't have a good explanation for why you would do that, and I can go back and... Let me actually go back and re-explain that a little more. Stephen Armstrong. So I kind of pieced together what I saw on that one website where they use like cosine theta minus sine theta. And then, well, Wolfram did and what Yana said in the information here. So it seems like the technique to do this is you want to take this number, square it, add it to this number, -1, square it, take the square root, and that'll be the radius. We can't just multiply or divide by it for free. We have to multiply by 1, so root 5 over root 5. And then I brought the over root 5 piece into each of here. So that's how I went from, like, I guess this step down here to this step. And so then I used a technique called equating coefficients, which is basically looking at each side of the equation and trying to match things up. So the coefficient on the outside, this r, matches with the root 5. We have a cosine theta here, a cosine theta there, so I knew that cosine alpha should be 2 over root 5. And then sine theta there, minus sine. So I know that 1 over root 5 should correspond with sine of alpha. But we don't, and so we end up with r is root 5, cosine alpha is 2 over root 5, sine alpha is 1 over root 5. We can't evaluate either of these two equations though, because that's not a unit circle, or at least it's some super weird angle. But what you can do is take sine alpha and divide it by cosine alpha, which is the same as tangent. And I didn't show my work here, but it's 1 over root 5 over 2 over root 5. The root 5's canceled. You need to have just 1/2. And then you can take the arctan of each side, and they give you that alpha's between 0 and pi over 2, so we don't have to worry about infinitely many solutions, but you get arctan of 1/2, and that's something that you can plug into a calculator, I guess. So you do the first part. Just 2 sentences, or no, we were only a single sentence into the problem, and we were struggling. Well, I was. I won't throw you all under the bus. And so I think doing this part was in the name of applying it to this water wheel situation. No? Were they just torturing us for fun? Where does this come up later in the problem? Okay. Oh wait, are they making me do the same technique here? I think they are. Calculus noun, torture for fun. I wish this was calculus. This is like really hard to pre-calc. Yeah, this isn't the first A-level problem I've seen and struggled with. These questions are not easy. Not even the last question of the exam. Oh, yeah, I bet. Model find the maximum height of P above the water level. I feel like we can do this well. I assume what they want us to do is to combine the cosine and sine in the same way we combined... Oh, wait. If you factor the 2 out, it's basically the same situation. Sounds good, critical. I want to try and work through this. It's a pretty long question. I'm going to want to try and work through it as much as I can. And then if Ipsum is still around, they had a question before, and then it will be on you. So if you want, I can at you or when I'm doing your question. Does the 0.5t mess this up? I don't think so. Okay, so maybe that wasn't for nothing. We can do ooh. No, I think it's okay. I think we can use this. Okay, maybe they weren't just torturing us completely for fun. I think this result does apply to this situation here. And it is going to help. I was thinking that we could just try to intuition our way around finding the maximum height. But it's not going to be quite so simple. It'll be easier to do if we combine it to one trig function. Okay. Let me not forget what R and alpha are. Word, follow me. I'm going to use alpha's arctan 1/2, even though they say to use a decimal. I'm not going to use a decimal. So our function h is 3 plus 4 cosine (0.5t minus 2 sine 0.5t). So I think where we can use the result from the last it's the same problem, just the previous part of the first part, is we factor the 2 out from the second 2 terms here. And then this, if we let theta equals 0.5t, matches with the thing that we just did. Root 5 cosine 0.5t, which is theta, plus alpha, which is arctan of 1/2. I think that's what they want you to do. A Helldiver 2 stream one day, or Plague Inc. I never played Helldiver 2. Plague Inc. I played a little bit of, but I do all my gaming on Twitch, and I don't know if I'm going to do those games. Oh, okay, and so I think this is what we want. We know that cosine is at best 1. So we don't even need to worry about the exact t where this happens. We just need to know that, or we can be assured that somewhere this thing eventually is going to be 1, and figure out what the rest of the expression is, and that's how we can find the height for, I guess, part B. B1. So plugging this one into that cosine, three plus 2 root 5 times 1, which is just 3 plus 2 root 5. I think that's my answer for B1, which is right. They do want us to get the first value of t when this happens. Okay, so B, part 1. So part 2, we need to get the time where this value occurs. So we know that this thing, it's P, but it's also H, so let's just plug it in for H. I mean, or we could even... We can even skip a step. We already know that cosine, it's going to happen here. So let's just solve that for t. You can also take this thing, plug it in for h, and work probably with this equation. But you're going to end up in the same exact situation where cosine of this thing equals 1. So let's just skip straight to the chase. So let's take the arc cosine of each side. Arc cosine of 1 well, we want the first time where this happens. Because technically there's infinitely many places where cosine of something equals 1, but we only want the first time, and that happens, I guess, at 0. Oh, well, we're going to get a negative number if we use 0. Okay, let me actually... Cosine of theta equals 1 implies that theta is... that the... Okay, yeah, like minus 2 pi, 0, 2 pi, etc. in both directions. We want to figure out which one of these thetas we actually want. I was going to say we want to choose 0, but I went ahead and did some mental math, and we get a negative number for t, and we don't have negative time. That just doesn't make sense in this context, because the arctan of 1/2 is a positive number, 0.464. So you subtract the positive 0.464 over, and you get a negative time. So we don't actually want 0. We want the next value that works, which is 2 pi. And now we can just solve this for t. 2 pi minus arctan 1/2, multiply each side by 2. 4 pi minus 2 arctan 1/2. Okay, let's see if that matches the answer key. Four pi minus 2 times 0.464 was the estimate they gave. 11.64-ish. Hey, let's go. All right. That's part B done. P is below the water level for a total of t seconds in a single revolution. Solutions based entirely on calculator technology are not acceptable. Ah, sneaky. The water level may not be of constant height. Bruh. Oh, wait, the water level. Okay, yeah, sure, that makes sense, I guess. Let's worry about part C first. Actually, we should just rewrite. Oh wait, I already did that. Oops, I'm bad. So for part C, what we're interested in is when the height is negative. So we can set up the equation whoops. Is less than 0 and solve this for t. So what we're going to do is we're going to subtract the 3 over to the other side and divide by 2 over root 5. It's less than minus 3 over 2 root 5. Now we have to take the arc cosine of each side. I bet you arc cosine is a decreasing function. It's going to flip the inequality. Let's actually check that. Okay. Like I thought. Yeah. Okay, so taking the arc cosine when an inequality involved is tricky because arc cosine is a monotonically decreasing function, so it's okay to, because it's always decreasing, it's okay to use it with inequalities, but it flips our sign because if you give arc cosine a relatively big number, in this case close to 1, it makes it smaller. Whereas if you get a relatively small number like -1, it makes it bigger. So that's why we have to flip this inequality. If it's increasing, like arc sine, you can just take the arc sine of both sides of an inequality and you're fine because it's not going to mess up your inequality. It takes a big number and makes it bigger, takes a small number and makes it smaller, or about the same. But arc cosine is the opposite, so we have to flip it. Okay. So we get 0.5t plus arctan half, flip it, greater than arc cosine minus 3 over 2 root 5. We also need to worry about okay, we actually need to go back to the we need a calculator for this. Well, So if we take the arc cosine of each side, it's going to give us the value of cosine that goes with 3 over 2 root 5 between 0 and pi, right? Because that's where arc cosine, well, wait. Isn't this graph? Oh yeah, between 0 and pi. Okay, that's the range. But there's going to be a second solution between pi and 2 pi. But first things first, let's do arc cosine of the thing we have. Minus 3 over 2 square root 5. We get this in radians. It's not anything pretty. I mean, 132.1 degrees isn't so bad. So like I said, that this ends up being in the second quadrant, so we expect there to be another answer in the third quadrant, where cosine is also negative. And we get to that answer by doing something. I think we do 2 pi minus this angle. Does that make sense? Yeah. Because we want a 132-degree angle, but like coming down over here, which is equal to doing 2 pi minus. Okay. So let me actually write down this decimal on the board, before you forget. Actually, let me write in a slightly different form. Cosine of theta is equal to minus 3 over 2 root 5. Just this simpler equation implies that theta is the ugly thing in radians, 2.306 plus 2k pi, because that's the period of cosine, 2 pi, and k is any integer you want. But it also implies theta is the other thing, 2 pi minus that thing, 2.306. $3.977. So those are all the possible values of theta. Let me actually verify that in Wolfram though, because this is always a really sketchy part of that's not the right thing. Cosine x equals minus 3 over 2 square root 5. This is a really easy thing to mess up, and I've been known to do it before. Okay, good. Wolfram Alpha said in a slightly simpler way than I did with 2 pi minus the cosine, or cosine of that thing, but that's fine. Okay, so we have our two answers. At least to the simpler version of this problem. This means that we get two, well, ooh. So, in the same way we didn't want theta equals 0 for the last one, we might not want k equals 0 here. We want positive times. Wait, is arc cosine weird? Am I missing something with arc cosine of inequality? I'm just realizing if you give arc cosine a negative thing, it might make it positive. Oh, no. That seems like an issue. Crap, arc cosine with an inequality isn't that simple. If you give it negative 0.5, well, no, that's still okay. No, I think it's okay. Yeah, I guess. I feel like there should be another spot where we flip the inequality is what I'm thinking in my head, because we should get t is bigger than something and t is less than something. Maybe let's not worry about that too much, because we can always, if we get the actual values, we don't have to worry about the actual signs that much. It's not really doing things properly, but it's good enough to get you the right answer. Actually, we should just go back to a calculator. Like, we should solve it for t with each of these values and see what we get, actually. Let's just, yeah, let's go back to Wolfram and make Wolfram do this. So I'm gonna take the last step that we just ended with, 0.5t plus 0.464, which is the estimate they gave. And I'm going to just do an equal sign just because I don't worry about greater than or less than. 2.306 was the first value of arc cosine that we got. What does t come out to be here? 3.684. Okay. And then I'm gonna what am I gonna do? Copy it, open a new tab into the other value of arc cosine that we got. Instead of 2.306, let's do 3.977. $7,026. Okay. So these are both positive times, which is good. That's what I was worried about. So let's go back to the board now. Yeah, it's fine. What we found is that 0.5t plus arctan a half is greater than 2.306 when t is greater than 3.684. And now the part that's a little weird is from the other one. $7,026. For 3.977, that I think at some point there's some type of logic that I should have done to flip this inequality. I think we should be getting that it's greater than this 3.6 and less than the 7,062, and that gives you like your clean interval. There's some little piece of logic in this part that I'm not understanding. But the important part really is that we figured out the two values where this thing occurs. And because we know the way that cosine is generally shaped like that, if you draw a line through here like this, and you're where you're below the line, we're probably going to be between these two values and not like outside of them. You do have to worry about that. Like you could be technically outside of these values rather than between them, but I'm pretty sure we're going to be between them because of the way the cosine is shaped. That's the only kind of like fault you could have if you are lazy with your inequality signs and flipping them. But figuring out the actual points where this happens, you can use your intuition to figure out whether you're between them or outside of them. Because inequality is just tricky. But yeah, so I would say the answer is, to be explicit for part C, 3.684 is less than t is less than 7026. And why that one isn't flipped beats me. Let's check that answer. Oh, they want the interval of time. Let's subtract the two answers. Is that 3.34? I think I'm pretty close, if I'm not exactly on. I have the actual time values, they just want the time where it's under the water. So we take our two answers and subtract them. 3.342? 3.34! Okay, I feel proud. That's, what? The 3 would need to be... That's a stupid answer for part D. Explain how the equation of the model should be refined to take this into account. Hello. So, okay, I read part D ahead of time, and I was like, this is kind of a weird problem. I saw you talk about that in Zach's chat. Apparently it's the absolute value of pi, depending on who you ask. Part D, I think it's just a weird question. They're saying this 3 here needs to vary, and that makes sense, but like, there's a formula sheet they give you. Oh, cool. You need to turn this 3 into some sort of function, is what they're like trying to say, because like this 3 represents the height of the water. I can't talk. The teriology knowledge, yeah. And so this piece of the model that you'd want to adjust is what they're saying. It's kind of a weird question, though, to me. B.S. Stephen Armstrong, I hope that helps. Ipsum, are you still around? Let me try typing their name in chat. Nigel Cheese? I'd never heard of him. Okay, that was a... This one kind of pushed me a bit with having these super weird values, and this technique for the first part was really weird, but at least we got through it. All right, I'm gonna give Ipsum another like minute or two to respond before we move on to criticals question. Let me erase the whiteboard in the meantime. Okay, not seeing Ipsum, let's move on to critical. Let's come back to Ipsum if they turn up later. Okay. Let's see what's up with this. See that Yanis took a look at it. Are you asking about part A as well? Oh, you're just asking about part B? Okay. I never used a partition matrix before. What the hell? Yeah, yo Tizzle. So you can either type it out there in chat, or you can put it in my Discord server. Oops. So this one that Critical just posted in the Discord server, you can post it in this math homework help forum or in the math discussion thing are the best spots to, oops, you can't see my cursor. Those are like the best two spots to like do it. Welcome by the way. If you're new to math streamers in general, let me shout out a whole bunch of them for you. Everyone in that list does math help of some kind, so if I'm not around and you have a question, people I can all like recommend highly. And hey, RT chess players. And also, I dual stream to Twitch and YouTube, so if you're on Twitch and you see me talking to someone who's in there, it's because they're probably on YouTube, and vice versa for anyone who's on YouTube. Trying to work on Terrence Howe's analysis in one book. Some exercises are quite rigorous. Oh, so he's using set theory as the building block for analysis. I guess that makes sense. It sounds like a pretty painful way to study analysis, though. Like that definitely wouldn't be, you wouldn't want to be your first analysis book. To use naive set theory. Yeah, fair. Are you a math teacher? No, I've been a tutor. I'm not an actual math teacher, though. I have a bachelor's in applied math. Charles Chapman Hughes. That rolls off the tongue well. I don't know what the hell a partition... I think that Yanis's image kind of explains it. But, like, is it actually as simple as that looks? I never received links from Brown University. Let's see what... This is a... These colors feel like an assault on my eyes. I'm kind of glad that Brown University doesn't normally show up. And look at how squished that image is. They took like the cover of a textbook and just squished it down to a square. Okay, I'm sorry. I'm not a website reviewer. Oh, that's fair, low. Yeah, I forgot. You do some like real math, I guess. Not like my math. Does block matrix multiplication work the exact same as regular matrix multiplication? Is that the idea here? Michael, I completely agree. This is I'm not a fan of this website. We all do read math, even Terrence Howard. All right, let's just do a little experiment. Oh, duh, the steps literally show it. Okay. Use partitioned matrices. Okay, I think I see the idea here, critical. Yeah, I never heard partition matrix in my life, I don't think, so I needed to, I guess, learn it quick. One can usually not switch the order. Yeah. So we have A is 1. I already forgot the rest of it. 3 minus 1. We have M is this big boy. 1, 0, 3, minus 1. All zeros in the upper right? Yeah. Identity down here, right? Right. Minus 1, 0, minus 3, 1. Okay. Those are written a little too close for comfort. Okay. So the idea here is that, as Yanis posted in the Discord, they want you to notice that this block of the matrix here matches A exactly. This part in the lower right is negative A. This part here is the identity matrix. And this part right here, I don't know if it has a special name, but zero matrix. I don't know. Zero matrix, probably what it's called. The important part is that evidently you can rewrite M as basically a matrix of matrices, where this is the matrix A, this is the zero matrix, this is the matrix I, and that's the matrix negative A. So these two things are the exact same, just with different representations. And you can use this to calculate M squared, because trying to do M squared on this would be long and painful, I think is the point. So if we use this block matrix thing, we can calculate M squared with these block matrices, and then plug things back in on the other end after. So if you do normal matrix multiplication on these two things, you do that column times that row. So you get A times A is A squared. 0 times I is 0. You do that column times that row. No, wait, I'm stupid. Wait, no? It's A squared plus 0 for the first entry. Then it's that column times that row. 0 times A plus 0 times minus A. Then this column times that row. A times I minus A times I. Then that column times that row. 0 times I plus minus A times minus A. When do matrices of a ring, so the entries are elements of the ring. Huh. That's weird. Yeah, and the determinant will be a matrix, I guess? I don't know. This is still a 2x2 matrix, by the way. It just looks like there's a lot of things in it. So that first one is A squared after the dust settles. This one is just 0. That one is 0. This one is negative A squared. And now here we can, this is still a block matrix, but it's pretty dang simplified now. They made us calculate what A squared is in the last problem, so let's plug that in here. Oh, we don't have that piece of the answer key. We can find it. My fan is squeaking. Whatever A squared is from the first problem, you just plug it in there, basically. Can I do mental math with matrices? That's kind of dangerous. 1 right there. 0 right there. -1 right there? +1. No. I'm screwing this up. That row, that column. 1 right there. That row, that column. Oh, maybe I did those two right. That row, that column, that row. 3 minus 3 is 0. It's just the identity? That's kind of lame. 1. Okay. So we know that a squared is the identity, so let's make this back into a 4x4. So a squared is that. 1, 0, 0, 1. We have a 2x2 of zeros here. That's what this 0 signifies. Same with that 0. Then minus a squared is just the negative version of that. Wait. That's not right. M squared equals I. I didn't get I for the result. Oh, I don't know how to square. I don't know what minus a times minus a is. It's minus a times minus a, which is positive a. Now it's I. Can you explain the last part again? So we got this for the result when we squared m, so I assume the last part you mean is going from this back to this. And remember where it came from, A was a 4x4 matrix, and we kind of, we split up into a bunch of 2x2 matrices. We made it into a 2x2 matrix of 2x2 matrices. So each of these entries here are 2x2 matrices on their own. So a squared, we already calculated previously as that. So we're going to take that 2x2 matrix and plug it in for this a here. So this red box correlates with this red box here. This blue box, this 0 signifies a 2x2 of zeros. Same with this 0. That a squared correlates with these there. No worries. Critical. Determine with the characteristic polynomial. Weird. Yeah, I don't know anything about like polynomial rings, so. Really about rings in general. Okay. Get some water. All right, so I think we have another slow part. God, it's freaking hot. I think my headphones off. Today's probably not gonna be like a super long stream because it's just hot and I don't want to think for that long. All right, Yanis, thanks for popping by and hanging out. Hope you sleep well. Yeah, Joseph. I shouldn't make that noise into the mic. I think it is louder than it seems. What should we do? Go back to the math Discord. Do I want to though? Or it's either math Discord or I think abstract algebra studying. Let's do algebra. Decisions. Let me look at what Penn Center recommended though. All right, I don't remember how far we got. 23? We've done 23. I don't think we've done 23. Have we done the one before it, 19? Oh, I saw Penn Center do 19. About 14 to 16. I did 14. I did 15. Pretty sure I did 16. The more I look at the algebra, the more I just want to like say that I'm done with permutation groups. What was the argument that Penn Center made for 19? Penn Center just looked at cases, and that's when I saw the problem, that's what I thought was the best approach. Because there's only 4 cases to look at, so it's really not that many. If alpha and beta are both even, then you have an even permutation times an even permutation, which is even. If they're both odd, when I say times, it's like you're adding up the number of permutations. So when you do an odd plus an odd, you get an even number. Then even plus an odd is an odd number. Is basically what the argument comes down to for 19. I think Anders found a really quick way of doing it that I don't remember. I'm going to go into cases, but I think the cases argument is good enough. For 23. Oh god, the subgroups of these permutation groups are really funky. And it's probably easiest to think of them as proper subgroup has to hold at least one of the elements fixed of the original S sub n, maybe? In which case it would be equivalent to, like, if you start with S sub 5 and you held one of the elements constant, fixed, you basically have S sub 4 with potentially different labels. I have my headphones off, Waffle, because it's just too hot, but I see you parkouring. Sorry, my ears are sweating. It's not good. How hot is it right now? Let me Google it. Not on stream though, because I don't want to save my city. It's 97 right now. Which it has been hotter, but like I don't have AC, so a cold front or something. Highs are only in like the high 80s. Oh, nice. That sounds nice. It's gonna cool down. Like, this is gonna be the hottest day for like a little bit. After today, it's gonna go down. It's like the low 90s or high 80s, I think, for a good little bit. But I really hate the summer. Trying to stay school here too, yeah. Hopefully. We had a really random, like, nice week, maybe like 2 weeks ago. It was in like the 70s for some reason, which is weird for July. Yeah, I'm still doing homework help. You got some of them? Let me throw away my coffee wrappers. 1 second. Hey, the spectating crescent. How's it going? Operations on matrices. Oh yeah, sure. Like, are you adding them, multiplying them, doing row operations, or do you have like an example problem? Or you're probably still typing. Don't let me ask you like a million cool questions at once. Yeah, sure. So I'm happy to like the basic stuff with matrices. I know. I'm not trying an Olympiad problem. Levy, in my Discord. If you are watching, because easy is relative. I don't know competition now. Nothing advanced. Okay, cool. Troll problem IMO 2024? Only because there's nothing else to do right now. I'm not actually doing it. I'll look at it, but I'm just not doing it. I don't know. Troll hole podcast? What? I don't know what problem this is. I don't want to watch a YouTube video. Is there an AOPS link? This? I don't think it's in that link. Oh, there. Is matrix to the T. Oh, okay, so that's not an exponent, that's a matrix transpose. Okay, so since Waffle put her question in chat, I'm gonna address that. So so you might see like a matrix A to the T, or you might see an actual matrix itself, like 1, 0, 3, 4, -5. Random numbers are hard to think of. -7, 10, 2. Why not? Or you might see like an actual matrix with a T up there. It's not an exponent. It's it means transpose. What it means is all the rows become columns and all the columns become rows. Or I usually think about it as you kind of draw that diagonal there and you flip things and you flip the elements across it. So this diagonal stays the same, but all these other ones like flip. This diagonal stays the same. Now this one up here is whatever that one is there. So 4, like the 4 and the 0 switch. The -7 and the 3 switch. And the 10 and the 13 switch. That's all a transposition is. Yeah, basically, Waffle, you could think about it like that. So yeah, I like this kind of like reflection idea, but I've also heard some people prefer it as like turning the rows into columns and the columns into rows. So I just said them both. But that's all transposition is. I think once you actually like, there's probably some properties that are helpful if you do like A times A transpose in some context somewhere. I don't know enough about linear algebra to give an example of that, but I think transposes do come up in with like, they have some helpful properties. And you also want to know about multiplying matrices. I guess let me know if that makes sense about like the transposes, and then I can like make up a matrix multiplication example. Okay, yeah. Let's start off with like a 2x2, because the idea will be the same for bigger matrices. Let's do that matrix times. Ooh. Okay, no, let's start off with 2x2 times 2x2. Okay, so there's a couple of things going on with matrix multiplication. Before we get into how to actually do it, let's figure out what the result should look like. So the rule that I was taught is just write out the sides of each of these matrices here, 2x2 and 2x2. And that's rows by columns. This will cut, for 2x2 times 2x2, it's like a kind of a nice case. You can do it like weirdly sized matrices times each other's though, which is where this will be more handy. But just to show you the rule, if these two numbers match here, you are allowed to do matrix multiplication. So 2 is the same as 2, so we're allowed to, like, you know, these two 2's are the same, so we're allowed to do it. And the result will be this number 2 by that number 2. So in this case, we're doing a 2x2 and a 2x2 to get a 2x2 out, but this rule is going to come in handy for other cases. And I'll do a few examples because it's going to, there's a lot like that goes on with this. Okay, so we need to figure out how to fill in this 2x2 matrix. Let me actually make some more room. So what I've done when I have like tutored students in person is I actually like write these matrices out onto paper and cut each of them up into squares, because I actually kind of, in my head, I visually rearrange the elements here. But the rule is in the upper left corner, this upper left corner here, we're going to fill it in with how do I even describe this? We're going to take this column times this row. And when I say times, we do the first thing times the first thing. So 2 times -1 plus the second thing times the second thing. It's like a dot product with vectors if you learn those, but if you haven't learned those, then don't worry about it. And so I kind of remember like this upper left spot is what you would get if you overlapped like the first row or the first column with the first row here. Like they would overlap right on the upper left there. That's kind of how I remember that. But I physically, like in my head, I move this row like up and over to be like 2 times -1 plus 5 times 12. Like I mentally need to like visualize that. And now we repeat this process for each of the other entries in this 2x2 matrix, and then we can like evaluate these expressions. So this in the upper right will be the second column times the first row. And again, it would like the first row and the second column overlap right in the upper right corner. So here we do the first thing 0 times the first thing 2, or the other way around. 2 times 0 plus the second thing times the second thing, 5 times 4. Let me make some more room. And now for the bottom row, we're going to do the same procedure, but we're going to take the first column again, now with the second row. So -1 times -8 plus 3 times 12. Now for the lower right, second column, second row. 0 times -8 plus 3 times 4. Okay, so who decided on these problems? I have no clue. Matrix multiplication is super weird. And I'm even struggling to explain it because I like can't easily do the explanation that I normally would, and even then that's not a perfect explanation, and this one is even worse. So I'll do a few examples and that'll hopefully help you see the patterns a bit, because it's just weird. But all we do now is like do this arithmetic here and we have our answer. So -2 plus 60 is 58. 0 plus 20 is 20. 8 plus 36 is 44, I hope. 0 plus 12 is 12. So that's our answer there. Let's do another example. You can guess that's the reason for it. I don't know the reason for it myself. I feel like Pen Center will be able to, like Pen Center Suki or Zach would probably know like that higher level answer to why it's like that. I feel like Pen Center explicitly like made references to explaining why matrix multiplication looks like that. I don't know it for myself though, so yeah, I just know the procedure, but the why is above my pay grade. So let's take a different 2 by 2 this time. 0, -2, 4, 6. Instead of a 2 by 2 over here, let's do a 2 by 3. So, wait. Really? I was picturing this wrong. 2 by 3 is 2 rows and 3 columns. Let's make sure that I'm actually like gonna get this right, but 3, 4, 9, -3, 7, sure. So that's 2 rows, 3 columns. Okay, and so yes, okay, this will work. So we have these inside 2 numbers are the same again, so we're allowed to do it. This time the result is 2 by 3 though. Go all the way up to the edge here. So it's still the same procedure, but now we just have like an extra column to work with here. So we would do first column. Yeah, honestly, like I guess the way I think about it is I go through each of the columns here and I multiply each of them by each of the rows, I guess. So you don't have to do it in this order. This is just the way that I think about it personally, but I always start first column with the first row going like right to left, I guess. So you do -5 times 0 plus 9 times -2. And now we go through the second column with the first row and we get an entry in the middle, the upper middle, 3 times 0 plus -3 times -2. Now last column, first row, 0 times 4 plus -2 times 7. And now we've gotten to the end of here, but we have to go back through the columns with the second row now. So -5 times 4 plus 6 times 9. Now that column, that row, 3 times 4 plus 6 times -3. Right? Yeah, it's really easy to lose track of numbers when you do this, but 4, now third column, second row, 4 times 4 plus 6 times 7. Now we just do a bunch of arithmetic here. -18, 6, 14, nope, -14. -20 plus 54 is 34. 12 plus 18 is -6. 16 plus 42 is 56. Yeah, nothing in linear algebra is quick, unfortunately. Let me catch up with chat here. I think it's good to know how matrix multiplication works, Ishan. Like, I don't think you should be made to do it by hand all the time, but... And hey, Pritam, I was just explaining how matrix transposition and multiplication works. Oh, it's about linear transformations? Okay. And T-Rocket, Trocken. I don't know why I'm struggling with that so much, but either way, yeah, the rows and columns, it's definitely a struggle. Okay, thank you. Welcome in. Sounds good, Waffle. But yeah, at least like the computations involved in linear algebra are usually super tedious like that. There's a lot of rearranging things and there's a lot of like arithmetic. So, but that's basically the idea and the pattern that you can use to figure these out. Prism, if you have a specific question that you can give me, then let me know, but that's pretty open-ended and there's a lot of different like I don't know what your level is there. Addition is much easier. I never ran exams in your book. Oh yes, Suna, I bet. Yeah, addition is so quick that I'll just like show you. Thankfully, that's nice. Oh, I should have said, matrix multiplication is not commutative. Or if it does commute, it's by sheer it's just like a coincidence. And when I say commutative, I mean that if you switch the order of these two matrices, you'll get a different answer, more likely than not. So this times this is not the same as this times this. What? Oh, that's a meme. Okay. Sheer coincidence? Oh god, I don't know what sheer is. Hey, $5. Or I've heard the term sheer. I don't know what it actually means though in math. Yeah, Waffle. And hey, Central. I shouted out your problem for organic chem if anyone was able to solve it, but I don't know if anyone has yet. I haven't checked. But yeah, for matrix addition, that part is relatively easy, at least. The hardest part is making up the random numbers, apparently. 10, sure. For this, you just do it like I think it's say element-wise, basically upper left plus upper left. So -1 plus 2 is 1, 0 plus 6 is 6, 3 plus -5 is -2, 5 plus 10 is 15. So that part is not so bad. Percent sure you got it right? Oh. I feel that. So linear transforming called a shear. Oh, okay. No, that's a good question. They do have to match exactly. Pritam, I would need like a specific problem to work on, I think. Like, are you in a calculus class or an algebra class, or like that's kind of like what I mean. Yeah, it just wouldn't be defined. And like the same thing with multiplication. If that like condition isn't true with the dimensions matching, there just is no definition of multiplication or addition if the conditions aren't met. You have like different physical classes for different parts of math in the US. Like I don't I guess exactly what you might mean by that, but like in like high school, so like 9th to 12th grade, you do have like I guess like different options. Like you would start with like algebra 1, geometry. When I was in high school, it's changed now, but algebra 1, geometry, algebra 2, pre-calc. Stats is like kind of off to the side. And then there's like calculus and AP stats or college level stats, just have math. Oh yeah, they have like the different names. And I mean, I think if you're 8th grade and before, it's just called math, but maybe Ishan, I'm not sure. Saw US TV shows. Oh, really? That's weird. Probably trucking, yeah. Whether that's okay or not will probably depend on the context. You're weird? I mean, I literally stream myself doing math for fun, so I can't say I'm not weird. You start. Oh, pre-algebra. Okay, yeah, that's fair. Waffle. I was in California. I was like the last class to graduate high school, and for the next year they're implementing Common Core, which these are my classes like guinea pigs. And to take a Common Core test, and it was super weird. I didn't get like all of it. If you're weird, what am I? I think you're ultra weird because you're studying math at a higher level. You know, I have a bachelor's in being weird. You're working on a PhD in being weird. You wear cool ties. That looks homeless. True. Olympiad math? Oh, I would much rather do matrix multiplication than Olympiad math, personally. Your brains hurt my brain. It's closer to geometry into linear algebra. Oh, I mean, geometry kind of sucks. I would not have minded learning a little less geometry and a little more linear algebra. Geometry haters. There's so many theorems. Too much memorization. My number one. Oh yeah, my number one fan. Thought it was. No, it's right there. Well, how do you know that's not also my mom? Yeah. Was it 97 Fahrenheit to Celsius? It's 36 degrees to today. That's my ceiling fan, I think, Zach. Sorry, Mrs. Math. Determinants. Oh god, all that's in one assignment? Yeah, sure, we can talk about the determinant of a matrix. Guess what? That might be even more tedious than matrix multiplication. In fact, it definitely is. Well, no, for 2x2, determinants are easier. But if you go to like 3x3 or higher, determinants I think are more tedious. Oop. Okay. Determinants. Let's start with the 2x2 because those have a. There's technically a couple of different methods to get the determinant of a matrix. I'm just going to show them that can be done by hand. Well, I mean, there's a couple that can be done by hand, but I'll show you the way that I was taught anyway. Let's start with the 2x2 because those are pretty quick, thankfully. Let's say you have 2, 1, 5, 4. Why not? Make a joke about rubbing the board floor. You're gonna distract. Oh, Obi. Thank you very much for the raid. Well, it's better than like having your hands covered in chalk, Zach. Yeah, exactly. Waffle nose. How's your stream, Obi? Thank you very much. Determinants area or volume? Oh, I didn't know Aishon. Chalk is the best. You're just saying that to annoy me, Central. No. Central doesn't actually care, I don't think. He just wants to disagree. The chalk scratch haunts my dreams. I love it. No, the texture of it is terrible. I hate it. Welcome in though, everyone from Obi's stream. You know, the chalkboard in school is elite. Oh, okay. We're just talking about some of the like fundamental properties of matrices. Lots of motivation to do extra problems. I'm feeling that. To my students' pre-calc project when you taught. Oh, cool. Alexis Sweetener's artificial. I haven't seen the B movie. Okay, so the determinant of a matrix. There is a little like notation difference where this means a 2x2 matrix. But this, with straight bars, means take the determinant of this 2x2 matrix. In 2x2s, it's just a formula that, as far as I know, you just have to memorize it. Let me actually show it generically before I do it with actual numbers. If you have a matrix A, B, C, D, and you want the determinant of it, goodbye, marker. You do A times D minus C times B. Or B times C. Whatever makes you happy there. So it's just multiply the main diagonal, subtract the other diagonal. So if we do it over here, 2 times 4 minus 5 times 1. That's a dot. So 8 minus 5 is 3. That's what the determinant of a 2 by 2 matrix is. Zach rage intensifies. I don't... Okay. I hate memorizing things in math, but I have no clue in hell why the 2 by 2, the determinant of 2 by 2 is like that. So you're welcome to explain it, Zach. Both thank you and hey. B-movie watch party. Oh, that'd be funny. Going to sleep part of the plan just happens when Dawn is live. So I just have this memorized. Can you explain? Sure, Ishan. If you can in text, it's kind of hard, but the area spanned by the car. No, I'd rather that's just weird. There's some things where I'd rather derive it each time to memorize it, but like I would get caught up on like the area of a parallelogram spanned by the columns. Well, I don't know. I can show you what that means though. It has to do with how you graph vectors. If we use this as an example, you could split this matrix up into 2 vectors based on the columns. You can do it with the rows too, but I guess apparently in this case we want the columns. 2, 5, and 1, 4. Or if you don't want to know, I won't tell you, but... It seemed fitting? No, that's cool. A vector, I'm probably gonna get yelled at again, but a vector is just a special case of a matrix where it's just one column. But we tend to call them vectors because they come up in other contexts too, or I know there's probably a better reason than I can tell you. But you can plot these just like they're x and y pairs. So like x is 2, y is 5, x is 1, y is 4. But instead of points, we draw arrows because vectors are arrows. 1, 2, 1, 2, 3, 4, 5. So the vector 2, 5, we go 2 to the right and 5 up. It ends there, we draw an arrow. Vector 1, 4, we go 1 right. My scaling is terrible. It's crossing over 2, 5, and it shouldn't. I'm going to draw it out there. No, okay. If I could actually draw, let me... I'm just going to not have the coordinate axes because I can't draw. But basically, if you plot these 2 vectors from the same point, you can kind of fill in a parallelogram. If you take this vector and duplicate it up here, you take that vector and duplicate it over here. And apparently it's the area of that parallelogram. I'm sure there's a formula for it that would match that thing there. Sounds good, Yotizzle. As soon as we're done with this, I'll look at that. They're pointy like vectors rocket from Despicable Me. Honestly, if that helps you remember it, then do it, because I have a lot of stupid ways to memorize things. So the scaling is still off, but at least it's not drawn to scale now, you know? I'm not trying to draw to scale. Shoelace theorem? Oh, maybe, yeah. Okay, yeah. Trust Zach over me. ChatGPT will make it better. But I mean, ChatGPT can't even draw. Maybe that's how bad my drawing skills are. Yeah, so that's the determinant of a 2x2 matrix. I can show you for a 3x3. That's where it starts to get a little more tedious. For a 4x4, it's going to be super annoying, and I wouldn't do like the entire thing of that by hand, but I don't know, or maybe I don't want to like overwhelm you. Do you want to stop there, or do you want to see it for a 3x3 as well? Shoelace theorem. I keep forgetting. The shoelace theorem has come up a few times. I just, for instance, picking up soon. Okay, no worries. If you ever want to know later, I'm happy to show it. Oh. Okay. Yeah, it does seem like a similar thing. No worries, Waffle. Oh, I'm sorry, Pretim. Yes, I was busy with the other explanation. Thank you for posting an example question. In Manimal, not really. I'm not too good with physics. I'm sorry. Okay, so I'm sorry. Yeah, Pretim over on YouTube asks a question, and then I'll look at yours, Yo Tizzles. I'm sorry about the wait there. Aeroplane flying horizontally. Boo, boo, boo. What's going on with this question? 1 kilometer above the ground. Okay, so yeah, thank you very much for providing an example problem here, because this is exactly, like, we have to do a little bit of extra work here that I didn't think that we would have to. Like, we gotta use some trigonometry here. This is so neat. Yeah, I forget when it's come up, but it does seem pretty cool. Okay, so 1 kilometer above the ground. Observed at an angle. Okay, so first off, let's just place ourselves, like the observer. Let's just say that we're here. The plane is flying 1 kilometer above us. Ooh. Elevation of 60 degrees. So I think that means if the plane is over here and the ground is here, I think that angle of elevation of 60 degrees means this angle here. And then if we later observe it at an angle of 30 degrees, it's moved away from us. And is like that. I hope I'm interpreting the wording of this right, though. So I think angle of elevation is usually like that. And this is after 10 seconds. Okay. So we know, or what we're interested in is this distance right here, where the plane starts versus where it ends. That happens over 10 seconds. So we have the time. We don't know the distance, though. We don't know how far the plane has moved from its starting point to its end point. So if we want to figure out its speed, we need to know speed is distance over time, and we only have time. So we need to figure out the distance. So we have a geometry problem hidden inside here that we have to figure out. And so what I would do here, there's a couple of different approaches. I guess let's drop lines down here and here, because we know that this distance is going to be the same. What we can do is we can use right triangles to figure out this distance and to figure out this distance, and then subtract the two to get just that. I think that's a strategy that we want to use here. So let's start by figuring out this distance here in blue. I'll draw a separate right triangle here. We know the height is 1 kilometer. The angle is 60. So using trig, we're interested in the bottom part of the triangle, like that distance there. So for this one, we want to use tangent. Tangent of 60 degrees is equal to opposite over adjacent. I'm going to say ADJ for adjacent. Now solve it for the adjacent. Just divide by tan of 60 degrees. What is tangent of 60? You can use a calculator for that, or I'm just going to use the unit circle, so it's going to be like an irrational number. I'll take a look at the Discord stuff in a second. I want to get through this problem first. Tangent of 60. Tangent is sine over cosine. Sine of 60 is root 3 over 2. Over a half. So we're going to get root 3 over 3 kilometers for that bottom distance there. But you can also just use a calculator and get a decimal for that distance. You don't have to do what I did there. Now let's get the entire length in green. And it's going to be the exact same procedure. One km, but now we have 30. So tangent 30 is equal to 1 kilometer over adjacent. Oops, can't spell. So adjacent is 1 kilometer over tangent 30. It's going to be that flipped, isn't it? Just root 3. Yeah. So I'm going to say the entire distance in green is root 3 kilometers. So the final answer, or not the final answer, but the answer for how far we've gone in this 10 seconds is root 3 minus 3 over root 3. And again, if you're using decimals there, that's completely fine. But we know distance and we know time, so we know we can figure out our speed. kilometers over 10 seconds. Do they request certain units? Kilometers per hour. So they're a little bit tricky where they give us seconds, but we do need to convert this to hours. So we are going to have a little bonus problem at the end here, but you can plug this into a calculator to get another decimal. Let's convert the seconds into hours though, and then I'll plug it into a calculator. So we have seconds, we want to get to hours. So there's 60 seconds and 1 minute, and there's 60 minutes in 1 hour. That's the trick that I use because the seconds cancel with the seconds, the minutes cancel with the minutes, and our final answer is going to be kilometers per hour once we do all this multiplication and division. It's still hot. I don't want to put my headphones back on. So we're going to do square root of 3 minus square root of 3 over 3 over 10. And then we multiplied it. No, bad. Multiplied it by 60 over 1. And then we multiplied it by 60 over 1. This comes out to be 415.7 kilometers per hour, which seems reasonable for a plane. I don't know if fast planes normally fly, but that seems about right. So yeah, Pritam, I'm sorry about the wait there. I hope that makes sense. Let me know if you have any questions about it though. Okay, what Ishan put. Okay, thank you for that explanation, but there's no way. I would so much rather just memorize it than do this. This is finding the area of the parallelogram from the area of the rectangle, I guess. Taking the total area and subtracting out the areas you don't want, maybe? Yeah. Maybe that's not so bad if you're used to it, but it's not that much to memorize in my opinion. That is like nice to know though. So thank you for writing that out. Okay, so I don't see anything else from Pritam. We have a question from Josue in the Discord at 323 and a question from XYXR at 329. I'm gonna go with one that was posted slightly earlier. A differential equation. Or is it so you just know this one? Oh, okay, fair. Oh, reduction of order. Which, if anyone wants to learn differential equations... Oh, that's you, Yotizzle. Okay, yeah, let's definitely do this question first. If you're... I should say, N-Simplex Pachinko, who just rated before, is actually running a differential equations class right now. On Mondays and Wednesdays. And I assume we'll be getting to stuff like this pretty soon. So if you're interested in, or if you have differential equations, like if you're gonna have a lot of them, like I can usually help. And then Obi is one who really who loves them, specializes in them. Critical. yes, you can. I have to get through this question, another question from Manimal over in the YouTube chat, and then it will be on to you. Not until Unit 3. Oh, never mind then. So that it won't be on this that quickly, but if you're interested in more like differential equations and someone who can answer questions, I mean, I recommend everyone in the list who I linked before, but and Simplex put Bachinko there especially likes these. Linear algebra next. Okay, nice. So I think for this one, we want to do reduction of order. Taking class in the summer. Oh, nice. No. You're going to hate me, OB, because this is another one that I just have memorized with the integrating factor. Actually, I don't even have it memorized. That's the worst part. I usually have to look it up. But we can make this into basically a first order linear equation, solve that, and integrate the result. We'll come back to this later though, because we need to do a little bit of setup here. True and fourth. Oh wow, okay, so you're in the home stretch there. I don't need to show the original comment. I'm going to copy it with characteristic. Really? Oh, sorry, you're teaching. Okay, but like for like this problem. Like, you probably could do, you could just treat it like any other second order equation, I guess. Non-homogeneous. Minus 108 cosine 6x. Where you go to for this one? Oh, okay. So I guess like there's two different routes that you could do. When I see this, my instinct is to make a substitution, or this is called reduction of order. We say that v is equal to y prime, which means v prime is y double prime. And then you end up with, oops. With a first order linear differential equation that you probably know how to solve, which we can certainly do. The only trick is whatever you get for v, you do have to plug it back in for y prime, and then you have to integrate it again to get your actual y. You could also do what Obi is saying and solve it like any other second order differential equation. I would probably do reduction of order personally, but it is a style preference. Oh, characteristics. I guess that probably makes sense. Yeah, I never even realized that characteristics would work for first order. And so, Yotas, I assume you by that you mean like the reduction of order is what you're learning. So let's go. I mean, if that's all you need to see, like we can stop it here. But I'm happy to like go through and solve the entire problem if you want to. I'll just continue unless I see you say otherwise. But yeah, I would do an integrating factor, which is the thing that I have memorized. The integrating factor is e to the integral, I think, of 6. Yeah, okay. Yeah, of 6. And I'm going to use t as wait, it's x. Dang it! Using x. I forgot. We already provided the cosine x. And that plus c toolbox method. Oh, fair, Obia. Actually, I don't think we want the plus c there. Just ignore the plus c. We'll bring it in the next step. So v is 1 over the integrating factor. Times the integral of the integrating factor times whatever the non-homogeneous part is. My understanding differential equation is pretty freaking memorized, if you can't tell. So I'm not very good at giving like the explanations for why things are the way that they are. But I can do them. That's not... What an annoying integral. It's going to be one of those cyclic integration by parts. Really? They couldn't have given us an easier one? Okay. Well... Yeah, sure, critical. Where's in Leibniz? You just know this one, Ishan? Oh, I don't know that integral, unless you mean, by this one you mean like something else. Okay, let's do the integration parts off on the left here. E to the 6x cosine 6x. Well, we do have a 6x and a 6x. They showed us a little bit of mercy. Is there Lubert? I mean, Yotezel's doing it with reduction of order, so I want to do it with reduction of order, but characteristics could definitely just be easier. We could do a substitution before I even think about integrating my parts. That'll make us have a few less constants to worry about. I shouldn't have used U. So I'm going to use U for integration by parts. Let's use something weird like W. It's a double of U. It's twice as good as U. There we go. So we just multiply it by 1/6, let's just say. So we're going to take, does it even matter which one we derive, which one we integrate? I guess not. U is e to the W. That's a W, trust me. dv is cosine W. dw. du is e to the W. dw. v is sine W. uv minus v du. So we get e to the W sine W minus, oh hey, it spells U. There we go. dw. Now we need to integrate that by parts the second time. Oh, okay, Lubert. I'm gonna try that another time, but dw. I'm trying to keep things like conventional the way that Yotezel was probably taught. So it integrates to negative cosine, which is annoying. It's not really annoying. I just always forget to put that sign on. This integral comes out to be uv minus v du minus e to W cosine W. I guess plus e to the W cosine W. Then e to the W cosine W, e to the W cosine W. Oh, true. I see. Okay, yeah, with like a product rule. So this is going to be minus, so we're going to add it to the other side. So it's going to be e to the W cosine W. It's equal to 1/2 of the rest of this stuff. plus cosine W? Mayhaps. We have a 1/6 in front and we have to unsub. So what we get over here hey, Felix. Okay, so it's going to be 1/6 times each of those 1/2, so we're going to get 1/12. Oh, and W is 6x. Plus c, importantly, because the c is going to get multiplied by the e to the 6x. Okay. Oh, this is, oh no. Oh, no, okay, it won't be so bad. I thought we were going to have to integrate this, and I just, it's the e's are going to cancel, thankfully. Y prime equals v equals, does 12 go into 108? It does, 9 times. Look at that. Minus 9 sine of 6x minus 9 cosine 6x, multiplying this stuff inside here, minus 108c over e to the 6x. So this is what y prime is, but we do need to integrate it to find what y is. And thankfully, there's no more e's in front of the sines and cosines, so you don't have to do that annoying integration by parts over and over again. You're going to divide the 6 out. Sine integrates to negative cosine. Yeah. So it's 3 over 2 cosine 6x plus 3 over 2 sine 6x. Wait, minus. Too many negatives. Check chat. Transform differential operators. Probably not the way that you know, or probably not. I bet you understand it better than I do. Transform a differential operator, like, I'm not sure exactly even what that would look like. If 12 goes into 108 9 times, 6 goes into it 18 times? Is that how that works? Yeah. So it's going to be plus, because negative 6x, like Obi is saying. 18c e to the 6x plus some other constant d. I think we're all good. That's our answer for y without the initial conditions. They do give us initial conditions though, right? Do you want to see that part of it too? Or is that good enough for you? Yeah, these problems are a little bit, this is a little bit of a tedious problem, but that's the technique. That's good enough? Okay, sounds good. Let's plug into Wolfram Alpha and laugh at some small mistake I made super early on that messed the entire rest of the problem up. Let's hope not, but let's make sure. C1 e to the minus 6x. Why is there... I have an 18 there. Actually, I got it right. Just the, did they absorb it into C1? They probably did that, yeah. Okay, yeah, they're just playing fast and loose with the constants. Okay, thank you for the problem, Yotizzle. Polylog function. I've seen Wolfram Alpha sometimes give answers with that syntax error. I don't know anything about it though. All right, Manimal over on YouTube, if you're still here, I'm sorry about the wait. Let me look at your question. Ooh, magnetism. You just want to understand the component direction. Parallel infinitely long wire is separated by a distance 8 centimeters. What is the B vector field 2 cm to the right of the left wire? To the right of the left wire. Wait, right of the, okay, yeah, somewhere around there. What? The magnitude of magnetic field B is mu I over 2 pi r, where mu is a constant, I is the current flowing through the wire, and r is the distance the point is from the wire. Direction is the right-hand rule of F equals IL cross B. A. I assume that's a cross product at least. I don't know this offhand. Maybe I'll research it off stream. Hey, Scrimp. I mean, B field. I don't get the transition from here to here. Yeah, Femvox. I think this was more asking about some type of math property involved in this problem, but I don't quite understand it. I haven't seen Manual type anything right now anyway, so they may have left. So we can always get back to them on Discord later. Maybe let's go to criticals. Mu0, yeah. I don't even remember that constant when I learned. I definitely learned about magnetism at one point. I don't remember mu not though. Yeah, let me mark this as unread and maybe come back to it another time. Let's look at critical. Okay. LU Factorization. Oh god, I'm gonna learn this. I think I've seen it. I think I've seen it called like LU decomposition. The name of the two different matrices? So I guess L is the lower triangular matrix, which hearing a lower triangular matrix makes me think that the zeros should be in the lower part, but I guess the numbers you actually care about and that you get are in the lower part, and the zeros are in the upper part. And the U is the upper triangular matrix, where the numbers you care about are in the upper parts, and the zeros are in the lower part. But this site is saying explicitly that L goes with lower, U goes with upper, if that was all your question was. It's saying that I think for maybe any matrix A, or maybe only certain types of matrices A, you can express it as the product of two other matrices, one of which is, I guess, a lower triangular matrix, the other is an upper triangular matrix, is all it's saying. Like, you can find the two matrices that will look like this for a given matrix A. Yeah, that's what I was thinking of too, Truckin'. Hey, Wello, how's it going? Also, that spells out lol, and that makes me laugh. But I've seen stuff like that. There's like there's like the eigenvector value decomposition that's like with lambdas. I mean, you can say lol too. I appreciate a good pun. And Felix, I see that question. That seems like the type of thing that would be possible, but I don't know that I know how to do that. Critical is asking just what the names of these matrices are, I guess, like what this actually means. But yeah, I'm not sure, Criticals. Is there something more that you want to ask about here? Eigen decomposition, that's what it's called. Like that's what comes to mind for me, but I think there's like a few other like types of forms of this. Which one is which? Well, I guess it's labeled, so I'm not sure. Apparently, a lower triangular matrix has zeros in the top part and actual numbers in the lower part. And the L is an upper triangular matrix, so the upper numbers are the non-zeros, and the lower numbers are the zeros. I guess the lower and the upper refers to the parts that you care about that don't have zeros. And I assume there's always ones in the diagonal for I don't know why they don't show it in the U, but yeah, like they say LU factorization, and they literally mean the matrix L times the matrix U. In that order, like L first, then U. U is not a... Oh, okay. I can't tell if this is just a really crappy, like... like if something went wrong with the formatting. Actually, something definitely went wrong with the formatting, right? Well, I don't know. I can't tell. The boxes are confusing. And things not being aligned is confusing too. Now you get it? Oh, okay. I'm glad, because I haven't seen this before, and I don't know how U was supposed to look, I guess. I don't know. If you got what you need, though, that's the important part. The heck? Come on. Okay, there. Okay, so yeah, I'm sorry, Felix, I don't know. I don't think I know enough about that to help you out with your problem. We're at the 3-hour, 10-minute mark. I might just wrap things up here because it's hot and I'm tired, and it seems like the questions have slowed down again. So I think it'll just wrap things up. So yeah, I'm just gonna cut the YouTube stream up here, and on Twitch, we're gonna look for someone to raid, I think. So if you're on YouTube, thank you. I'll be back on YouTube on Thursday. And yeah, thank you, YouTube people.